Hey guys, welcome to Babyplane channel. This is our very first video on this channel. We plan to present to you all cute baby-like model planes, no scale models, just cute, chonky, little baby model planes. This baby F4U Corsair is for a start. Look how cute he is, chonky, he looks angry but still cute. All Babyplane models will be designed to be able to fly nicely, and we will show how to build them and share the drawing plans for to build your own Babyplane. Make sure to check description of this video for drawing plans link. All plans will be in PDF file format. We use mainly 3 and 5 mm foam board for the build material. Foam board or Depron, or polyfoam, they are basically the same, XPS foam. The wingspan of this plane is about 40 inch or 1 meter in length. The flying weight is about 2.2 pounds or 1 kilogram. It uses 750 kV Bell motor with 12-inch propeller, 40 amp ESC and 3S2200 mAh LiPo battery, 4 micro servo for aileron, rudder and elevator. You can also use 35-36 size motor with 1200 kV with 12-inch propeller. Not all flight were successful, like on this maiden flight, the plane was unstable at first due to miscalculate the CG or center of gravity location and aileron trimming to the right. We done all the trials and errors so you don't have to. Luckily the pilot managed to land it safely and undamaged. Some mishaps also happened.
Yeah.
Normal to tail dragger plane, you need to hold the elevator up until it took off to prevent the nosedive like that. Meet our builder, Hendy Sasanto. Hendy will show you how to build the plane. He starts building from the wing root part by attaching 5 mm foam spar and formers onto 3 mm outer skin. He then bends 3 mm foam top skin with the help of heat gun. You can see the foam is pre-covered with packing tape to protect it from breaking while in bending process. After the top skin is curved, he then closed the wing root segment. He continue the work by gluing spar and formers to the outer wing segment. He then adds stack of 5 mm foam to the 3 mm bottom skin to reinforce it, as that spot will be the main landing gear position. Like the wing root segment, he finally closed the outer wing segment with 3 mm foam sheet. He uses paper masking tapes to help the work. The tapes will hold each parts in place until the glue is set. Hot glue will cool down and hard in about a minute or two for maximum strength. He then glue the wing root and outer wing segment together. He fill the gap on the seam with hot glue and then wipe it clean with a piece of scrap foam. Now he can cut the aileron and prepare it. He adds stack of 5 mm foam inside the aileron to fill the gap like this. He make a slope profile on the aileron leading edge so it can move freely with the hinge on the top edge of the leading edge. Look how he closed the aileron cut gap here with 5 mm foam. You have to close it to keep the rigidness of the wing. He then used packing tapes for aileron hinges. After the ailerons are completed, he connect both wings together. The plane looks cute and stable but also has a huge drag, so you have to watch and maintain the throttle above 60% for safe cruising speed. The plane flies up and down, it's because the pilot had to hold the elevator up all the time to be able to fly level. It caused by too much down thrust angle on the motor. Refer to plans for the correct angle of motor down thrust. Now he start building the fuselage by covering all parts with clear packing tapes. Tape covering can protect the foam from breaking while bending and also make them stronger, so it won't easily crack or break when the plane hard landing or other mishap. Before assembly the parts, he bend and curve the foam into a cylinder by the help of heat gun. You can also rub the foam against the edge of the table or a rod to curve the foam without heat gun. The tape covering can protect the foam in the process. He then slide a 5 mm foam former inside the 3 mm outer skin cylinder to maintain the shape and glue it in place. Sand the lower edge of the inside side so the part will fit perfectly with previous part. Glue the part bit by bit every 2 or 3 inch until all edge is glued. He continue building the center segment of the fuselage. There are 3 big segments in the fuselage. Glue the segment to the previous one like this. Glue it every 2 to 3 inch or 5 centimeters until all edges are attached. He then closing the top part of the segment. This is the cockpit part. This is the last segment of the fuselage, the tail part. He glue and secure the tail tip first before shape it into a cone-like shape like this. Sometime a former doesn't fit to the part, because of error in tracing or cutting process. Just sand all edges uniformly to make it a bit smaller so it will fit perfectly to other part. He attached the last segment to the previous segment to complete the fuselage. This plane decal uses a popular and historic decal set. F4U Corsair No. 29 was used by American flying ace of World War II Lieutenant Ira Cassius Kepford, who served with a land-based unit of the United States Navy. In 76 days of combat flying with the VF-17, Jolly Rogers, he was credited with shooting down 16 Japanese aircraft. Hindi cut the belly of the plane to install the wing using templates from the plans. He is carefully cutting the belly slowly, because he know he can't make mistake here, it will ruin the plane. He traced the fuselage position on top of the wing using a pen and then remove the covering around the tracing lines. You have to remove the covering to have a good bond from glue. He adds strips of 5 mm foam inside the belly cut, to add more area for the gluing. Fun fact: The inverted gull wing shape on F4U Corsair was chosen to accommodate a large propeller so they don't need to design a very long landing gear strut. When throttle were suddenly advanced, the left wing could stall and drop so quickly that the plane could flip over with the rapid increase in power. This problem were later solved through the addition of a small, 6-inch or 15 centimeters long stall strip to the leading edge of the outer right wing, just outboard of the gun ports. This allowed the right wing to stall at the same time as the left. He cut slots on the tail to insert the horizontal stabilizer part using template from the plans. He then make a slot 2 on top the tail for the vertical stabilizer. Sand rounded smooth, all the edges on the vertical and horizontal stabilizers. Look, he didn't cover all the stab yet for this process. And then he covered them with packing tape after sanding. Look how he only cover one side to prepare the rudder like this. He then cut the elevator out from horizontal stabilizer part. He dry fit the horizontal stabilizer but doesn't glue it yet, he just want to adjust the slot size. He then insert and glue the vertical stabilizer to the tail, make sure the bottom part reached and glued to the bottom inside of the tail like this. And then he cut the vertical stab through the slot on the tail to make a way for the horizontal stabilizer to slip through. After adjusting and trimming the elevators, he then glued the horizontal stabilizer. Just like the aileron, he uses packing tape as hinge for elevators. This detail part is the final part before going to paint job process. This plane is very easy to land, the easiest among tail dragger type of model plane he ever fly, said the RC test pilot Julius. Before applying paint, he installed all servo first. He used 9-gram micro servo for all control surfaces. Here he cut a servo hole on the wing. He makes sure the servo arm is on the center position by using a servo tester before gluing inside the wing. He checked the control horn position before secure it with glue. He perform a bending on a 1.5 mm steel rod for control push rod. It's known as a Z-bend. He solder both aileron servo cables into one input like this. For rudder and elevator servo, he stacks side by side 2 servos like this, and he also made a foam platform to hold them together. Look how he make a battery platform from 2 stack of 5 mm foam, and he glue it here, just in front of the wing. He also glue a Velcro strip on that platform. And then he glue the tandem servo for elevator and rudder just below the cockpit. He adds small plastic straws there to guide the control push rod later. He then sand all packing tape covering with 240 grit sandpaper before applying paint. This way can make stronger paint bond to the tape, because you will have chipping paint on the tape without sanding. He uses lacquer spray paint like this. He apply the lightest color first, which is white, and then light blue, and finally navy blue for base color scheme. He covered the cockpit part with vinyl sticker and paint it black. He supposedly glued the 2D pilot there and attaching mica plastic for the canopy, but unfortunately the camera wasn't rolling when that's happened, so here is the result. In here he show us how he connected both servo to the push rods and ended up on elevator and rudder. You can see the elevator servo has 2 push rods to each separate elevators. And here where the battery will be placed. He then glue the wing to the fuselage after make sure all the control surfaces are in working order. You can see there, the 2 cables below the wing are from rudder and elevator servo. He applied decals from printed vinyl stickers to the plane. The decal file is also available for download. Make sure you check description for links. Here how he prepare the belly of the plane so it can be detachable. Its function is a battery hatch door and to access RX and ESC that are placed below the wing. He installed the brushless motor by using 10mm plywood as a mounting base like this. He used DST 750 kV bell motor. The motor has right and a bit down thrust angle. You can see the amount on the plans. This how the landing gear looks like. You can see the plans for detail drawing, both also with the tail landing gear. This is our next project, a 6M0 World War II Japanese fighter plane. Thanks for watching. Don't forget to subscribe and click notification icon so you can be notified if we release more new cute chonky baby planes.